over this, and then I'm going to hand back yesterday's test. We're going to go over it. Okay? You can't write on it, but you can write things in your notebook if you'd like. So you checked your odd numbered problems. Let me give you the answers to the evens. Number 6 is C as in cat. Number 10, Newton's first and second laws talk about acceleration. So when the acceleration is 0, either you're at rest or you're moving with a constant velocity. It's impossible to determine whether you are at rest or if you're moving with a constant velocity. You know you're just doing one of those two things. You just don't know which one. Okay, the next even is 12. 12A is true. 12B is false. 14 is B as in boy. 18 is choice C as in cat. 20 is choice A. 22 is no. Did you have to say anything more than that for 22? Can the line remain horizontal? No. And the reason is because there are vertical components of tension that have to be offset by the weight of that. So therefore, you're going to have an angle on the ropes. There's no way for that to be horizontal. And that's it. Anything you want to go over? Matt? Number 14. Okay. So 14, the answer is B. Let's go over why that is. So this is on page 107 in your textbook. Okay. All right. So 14 says that we have a girl holding a bird in her hand. The reaction to the weight of the bird is what? Okay. So let's talk about what the weight comes from. Weight. That's the force of gravity. That comes from the earth pulling on the bird, right? That's what it comes from. So what's the reaction to that? Same objects, bird and earth, but they pull in opposite directions. So that would be the bull pulling on the earth. Now, which way does the earth pull on the bird? Pulls it down. So that means this one has to be up, opposite direction. That's the reaction. And that's what it says in choice B, right? Gravitational force of the bird on the earth. We know that gravitational forces, all forces come in pairs, action, reaction. So this is the action. That would be the reaction. It's also a gravitational force. And what you learned in Regents is that it acts between those two objects with mass that are separated by a distance. So that's where that comes from. This will be studied more once we get to chapter 9. All of chapter 9 is about that. So don't worry about that yet. Just understand that force is, there's an action reaction. Anything else? Emma? Number 20. Number 20 says that we have a skydiver with a weight of W descending near the surface of Earth. What is the magnitude of the force exerted by her body on the Earth? It's the reaction to that, right? The weight that she experiences is from the Earth pulling on her. So I'm asking you, what is the force of her pulling on the Earth? Same two objects, action, reaction, so it's got to be the same amount, A, W. Anything else? I'm sorry? 12. 12 shows us this table. Oh, nope, that's problem 11. 12 asks you if these are true or false. So 12A says, if there are two external forces that are both equal in magnitude and opposite direction acting on the same object, the two forces can never be an action-reaction force pair. That is true. And the reason is because an action-reaction force pair act on different objects. Just like in this example, Olivia, the earth is pulling on the bird. So this is the object that this force is acting on, the bird. This is the reaction to it, but what is it acting on? It's acting on the earth. So they're never acting on the same thing. They're acting on opposite objects, okay? So that's why A is true. So what they're describing in A is this scenario. Here's an object with force 1 pulling this way and force 2 pulling that way. Are those action reaction? No, they're not. Okay, so that's why that is not an action reaction force pair. That's a balanced force pair described by Newton's first law. Okay, B, action equals reaction, but only if the objects are not accelerating. In other words, does Newton's first law Newton's third law only apply if you're not accelerating? No, it acts all the time. It's true all the time, 100% of the time. So that's why that's false. Anything else? No? Okay. Then I need you to just keep out your notebooks and let's go through and go over your test. You may not write on your test. You may not write on your test. You can write in your notebook if you'd like. And what I'm going to do is do the test in front of you. I have a clean copy and I'm going to do the whole thing and I'm going to show you what you had to do to get full credit, to get 100%. In terms of a curve, here's how I do it. This is how part 1 and part 2 are scored on the curve. You can figure out how the curve works after I show you this is the method that I go through. So yesterday's test was worth 30 points. 30 minutes is 30 points. Multiple choice is just the number of questions. So yesterday's test, let's say you got 16 out of 30. What I do is I divide that out on my calculator. You'll see 16 divided by 30. That's a bad number. Let's see if I can make this a little easier. Let's do 15 out of 30, just so I don't have a repeating decimal to write down. 15 out of 30 we know is going to give me 0.5 on the calculator, right? What I then do is I take the square root of that. And that gives me your grade. I then multiply that by 100. It's called the square root curve. So if I do that, 0.5, take the square root of 0.5, you'll see that means you're going to get a 71 reported as your test grade. That's called the square root curve. Okay? That's how this is done. And that's how most AP teachers across the country grade for physics. It's a square root type of curve. So you can figure out what you got to get raw score on each part as a percentage in order to get the grade you want in Aspen. So, and then I don't curve anything else. I don't curve your final quarter grade because it's already been curved. You know what I mean? So, okay. So let me hand back this. Do not write on this. And then pay attention because I am going to go rather quick because you've already seen the questions. Yeah. These are in no particular order. And I didn't show you how to fix the questions. I just took the points off when you did not do things correctly. So just close up your textbooks so you're paying attention to this. You can look at your textbooks and work on the next homework assignment afterwards. And you won't get to keep these. I do have to collect them all back at the end of the period. Well, as soon as I finish going over everything. All right. I'm not going to tell you how points were awarded, but let's pay attention. Question 1, please. Eyes up front. Turn to question 1. So they described this steel sphere being dropped from various distances. There's a recording plate down below, which is going to, this steel sphere gets released. This whole system is using electronics to determine the time of fall from the release point. So that's going to be a very accurate system. Just the speed of light is going to mess things up in there to give us variations or inconsistencies, incorrect answers for time. So the first thing they want you to do in part A is draw a smooth curve. Can't be bumpy. It's got to be one smooth curve. So if you have all kinds of bumps in it, you're not going to get credit. So what you want to do, you can see that this is going to form a nice parabola. What you want to try to do is make it as smooth as you possibly can. I'm going to start up here. And then you can go back with your pencil and you can try to smooth it in as best you can. It should hit almost every single point. Something like that. Okay, I don't want to see any wavering. So that's why you're using a pencil, so you can make these corrections. Now, obviously, that is not a linear graph. So now I want you to tell me with D and T how you linearize this. This is what we've talked about in the lab. You can only use D and T in your answers. If you have any other letter like V or A, it's wrong. There's no D or T in a V. Okay, yeah, you might use D and T to calculate a V, but that wasn't what they told you to do. You can only use these variables. So how do you change this to linearize it? You plot, as we learned in the graph, D versus T squared. You can't use X and Y. X and Y are not D and T. Next. Now they want you to plot those points, make the graph. And it does say to label the axes. You didn't label the axes, and you're not going to get credit. So on the Y, we need to keep the distance in meters. On the X, we need time squared in seconds squared. If I remember right, this works out really nice. We don't have to use the whole thing. And I'm going to keep the same scale they had all the way up to 2.5. So 0, 0.5, 1, 1.5, 2, and 2.5. And then what usually we do here, since I have to linearize stuff, usually what they're going to do is give you like another row or another column in the data table so you can write down your values. I'm going to do that real quick. So the time squared for each of these, this would be 0.0196. 0.32 squared is 0.1024. 0.46 squared is 0.2116. 0.59 squared, 0.3481. 0.63 squared is 0.3969. So roughly 0.02, 0.10, 0.21, 0.35, and 0.40. Those are rough answers, right? Approximations. That's good enough for the graph. So let me now go ahead and plot those points. This would be the time squared in seconds squared. So I need 0.02 and 0.10. 0.1 would be here. 0.02 would be there. Now I'm going to have another data point at 0.5 on the Y and 0.1. That would be there. All right, the next one is at 1 and 0.21. And then my next one is at 1.7 and 0.35. And then finally 2 and 0.40 right there. And now I have to, it says, oops. Now I have to draw in the line for this, right? It says sketch the best fit line. So I can see this is going to go nicely towards the origin. Almost every point is on this line. There it is. Okay, gentlemen, eyes up front. I'm teaching you. You're not discussing with each other right now. Now what we want to do is find the slope of this. It says use the slope of your graph. Slope of your graph. So that means you got to calculate the slope. You should always show an equation, because when we grade your exams, it's not like in Regents where there's a certain format for how you do a calculation that we're grading little parts. We are grading your thought process, which means if it's not on the paper, I can't give you credit for it. Because your thought was all of a sudden that answer just came to you. Okay, that you get no credit for that. You have to show your thought process, what's going on up here, in order for me to give you points. So usually when you do a slope, you pick 2 points that you're going to use. I usually suggest picking points where grid lines intersect. Those are pretty good. So that means I'd have 0.0 meters as my second point. The first one is 1.5 meters, 0.0 meters. The second is 0.3 seconds squared and 0.0 seconds squared. So 1.5 divided by 0.3 gives me a slope of 5.0 meter per second squared. But the slope is not the acceleration. It's not. Now what I have to do is figure out what is that acceleration due to gravity. And what I'm going to do is I'm going to try to write the equation for this. The equation for this, which is a line, y is the distance, m is our slope. What's on the x? The variable t squared, and there's no y-intercept. It's 0. So now I'm going to use this to try to compare it to the kinematics equations that I know to help me find my acceleration. Or you could take this and do the second derivative to get the acceleration. You understand what I mean? Oh, sorry, not 0.5, 5.0. I'm going so fast, I'm messing myself up. Thank you for pointing that out. So you can either do the second derivative or you can compare it to a kinematics equation for uniform acceleration, like that, where it was dropped from rest. So the displacement is 1/2 the acceleration times the time squared. And take a look. What does that mean? There's my d, there's my t squared. So what is that? That's what's left. 1/2 the acceleration. So that means this acceleration, which is the acceleration due to gravity, based on what I calculated, is about 10 meters per second squared. That seems pretty reasonable, right? A lot of you got the 5 and said, oh, that's the acceleration of gravity. Where the heck did they do this experiment? On Mars? Or the moon? No. Okay, there's no way this kind of equipment gave you that kind of error. 50% error is about what you're getting. All right? So that means you have a physics understanding problem, not any issue with the experiment. You have an issue with your understanding of physics. And this is what you have to do. You have to try to compare it to known physics equations to help you figure out what the slope represents. Okay? And doing it, linearizing it, helps you do that pretty quick. So there's my acceleration, not very big percent error. So state one way you could improve the accuracy of the results. Accuracy, not confidence. Confidence comes from precision and repeatability. And we discussed when we do every lab, what do we want to do to improve your accuracy? You want to increase the number of trials performed. Because why? Notice it then says, explain why. Why do we want you to increase the number of trials that you perform? What does that do? Maddie? That's right. This eliminates random errors. That's it. That's all you have to say. Just increase the number of trials performed to eliminate random error. That's it. Questions on number 1? That was half your test grade. Question 2. This was basically a Regents physics question, but on an AP test. First thing I want you to do, it says, draw and label the vectors for the acceleration and the velocity here. And they tell you it's rotating at a constant rate. So this is uniform circular motion. We should remember that the acceleration of something in a circle is towards the center, and the velocity is always tangent to the path. 1 point each. Now find the speed. What did they give you? They gave you a mass, they gave you a radius, and they gave you the period. How do you find the speed with that? You use the equation for speed, which is circumference over period in a circle. You then plug in 2 pi times 0.14 meters over 1.5 seconds, and that's going to give you 0.59 meters per second with the correct sig figs. That was it. Right? You learned this in Regents, didn't you? You learned that in Regents. There's nothing new here. Next. Now, this was a projectile motion question at the very end, but it starts off, but can you read a graph? Can you read a graph? That's what the first 3 questions are about. The first question wants to know which times the cart's at rest. When you are at rest, that means your velocity is 0 meters per second. You have the velocities. So come down. There's your 0. Where do we hit 0? Right there and right there. So the 2 times you needed to give me were 4 seconds and 15, 16, 17, 18 seconds. Those are the 2 times you had to give me for when you're at rest. Now, indicate every time interval for which the speed, which means the magnitude of the velocity, is increasing. These are your velocities. How do you go to increase your velocity? You go from 0 to a bigger number. You either need to go up or you need to come down. That's it. That's the only way you increase speed. You learned that in Regents too. We went over that with you in Regents. So where does that happen? That happens between here and here, which is between 4 seconds and 9 seconds. And then, nope, this is slowing down. That's constant speed, slowing down. Now I'm going to speed up again. That's 18 seconds. And that ends at 20 seconds. You got 1 point for each correct time interval. Now I want you to find the horizontal position at 9 seconds if we start off at 2.0 meters. I think the easiest way to do this is by using the physics equation on your AP reference table. X equals x0 plus v0t plus 1/2 a t squared. Since I'm moving from 0 to 9 seconds, I can see I've got a diagonal line, which means I have a uniform acceleration. The acceleration is found by calculating the slope of that line, which means I'm going to take my final velocity, subtract my initial velocity, and divide it by that time interval, which is 9.0 seconds. So when I work that out, negative 1.8 divided by 9 gives me an acceleration of negative 0.2 meter per second squared. Now I have everything I need in order to plug in. What is my initial position? That's right there, 2.0 meters. What's my initial velocity? It is 0.8 meters per second. How much time are we talking about? 9 seconds. Plus half of the negative acceleration, that is a negative slope, times 9.0 seconds squared. You do the math and you get 1.1 meters for that position. There were lots of different ways you could have done it, but I think that was probably the easiest. All right, now the cart goes to the end of the track and it goes off the track, landing on the floor. Basically, here's the situation. Does that. It's a projectile now. All right. And we know that this height is 0.40 meters. So I want you to find all of the following things. And I'm going to make my givens chart like most of you learned how to do in Regents. What do I know about the X and Y directions? In the X direction, I know that the acceleration is 0. In the Y, it is negative 9.8. I know my initial velocity in the X direction comes from the graph. I read over and I see that the velocity it's leaving the track at is 0.8 meters per second in the X direction. In the Y, it's not moving vertically when it leaves the track. It's going horizontally off the track. What else do I know? And I know the vertical displacement is negative 0.40 meters. It's going to go down 0.40 meters. That's all I know. First thing I want to know is how much time it takes it to land. Which column am I going to use to help me get the time? The Y. Why am I going to use that? Because that's where I know more. So the equation I would use is this one. Displacement is initial velocity times time plus half the acceleration times the time squared. This is 0. So negative 0.40 meters is 1/2 of negative 9.8 meter per second squared times this time squared. You solve it for the time, and I believe I don't remember what it was. 0.29 seconds, I believe, is what you get with the two sig figs. Oops, sorry, meter per second squared there. Okay, now I want you to come up with the horizontal distance. Well, that time now goes back into the chart because I can use it now in both directions. Now I want that right there. I'm going to use the same equation, but I'm going to use it in the x direction. That means the acceleration is 0 and goes away. So I'm going to figure out that horizontal distance by taking the 0.8 meters per second and multiplying it by the 0.29 seconds. And that gives me a displacement of 0.23 meters. Now, I want to know the speed that the cart hits the floor. So when it's hitting the floor, let's say this is the floor, there's the car. It's moving outward with the same speed, but it's also going down. The speed is that vector right there. Well, it's that arrow right there, I should say. It's the combination of the x and y components added together. So the first thing you got to do is figure out how fast it's moving downward at that point. And I'm going to use v is v0 plus at applied to the y direction. So that means I'm going to take negative 9.8 meter per second squared times the 0.29 seconds to figure out how fast it was moving downward. So 9.8 times 0.29 tells me that in the vertical direction, it was going down at 2.8 meters per second. So now I have these values. How do I get the v? I use Pythag. So that means I'm going to take 0.8 meters per second, square it, and add it to the 2.8 meters per second, square it. So 0.8 squared plus 2.8 squared, take the square root of that, and that gives me a speed, an ultimate speed of 2.9 meters per second, which is my final answer. And that's the whole test. Was there any calculus on this test? On this? 0. Was there anything really new on this test? This. Doing this. This was the only new stuff. Everything else here you learned last year, or were supposed to learn last year. And that is why I have told you, you need to go back and look at your AP summer assignment and check anything you missed. It's still showing up. I'm not just testing you on new stuff. It's not like physics begins this year and everything you learned last year is out the window. No, we're building on top of what you learned last year. So it's really important that you go back and look at that. I'm going to leave that AP summer assignment, Google Classroom, out there until the end of this month. Come November 1st, it's gone away and you won't be able to see it anymore. I'm archiving it. All right, so it will disappear out of your courses in your Google Classroom, which I know for a lot of you is like, thank God, get rid of all these other classes that aren't active anymore. All right, so please take a look at that. You are responsible for that, and that's how testing goes in this class. Okay, any questions? Those were all old AP exam questions. I don't make up questions for AP for your tests. They come from the many years of AP exams for physics that have been given. So, all right, I'm going to stop that. You have the rest of the class period.